to set the stage for the experiments you're going to do, it turns out that this Ibn al-Haytham, we're going to reproduce some of the experiments he did 1,000 years ago. And his name, as I said, El-Azain or Al-Hassan, we see this transliterated into European languages, but his name goes by many different names. So as an outline, I've already told you some of the stuff, how the lenses were used. We're going to mention quickly optical scientists. One thing we are knowing better now, that we don't use the term Dark Ages anymore, that it really wasn't the Dark Ages, but we call it a medieval period. Another misconception, which unfortunately still is common, is that civilization advanced rapidly. There were the Greeks, the Romans. It advanced to, I don't know, about 500, and then it stalled. The knowledge wasn't lost. It sort of ended up in Arab libraries, static, and then 1,000 years later, 1,500, things crank up in Europe again, the knowledge gets transferred back, and now we have Enlightenment in the European times. So the Arabs basically just were librarians holding things. Turns out that's wrong. And we're going to see the developments of science during the Arab Golden Age. I'm going to talk about the theories of vision, because Ibn al-Haytham developed our modern theory of vision, and a couple examples of his influence on Western culture, and then the workshop that you guys are going to be doing. So these optical scientists in the Islamic world, we're going to concentrate on Ibn al-Haytham. He was born in Basra, died in Cairo, wrote about 180 tracts on mathematics, astronomy. He was a pre-Renaissance man. He came 500 years before the Renaissance, and he was widely influential in huge areas of culture, and then died in Cairo. I was lucky, I was invited to Cairo 6 months ago. That's the mosque where he did all of his work, and so I visited the mosque where Ibn al-Haytham did all of his work. Presumably he sat in that library doing this stuff. His work was translated into Latin around 1230 and translated into Italian. Then it appears in various modern forms where it was highly influential. This historian of science said he was a significant figure in the history of optics between antiquity and the 17th century. I would say this understates his significance, in fact. So we look at theories of vision prior to Ibn al-Haytham. They fell into three major categories. There were extra-mission theories of vision, and two widely known proponents of this, Euclid and Ptolemy. And the extra-mission theory was that our eyes emitted particles of light that illuminated the scene, and that's how we saw stuff. Now you think this is silly. They knew this was wrong too, but it gets the geometry correct, so it's kind of hard to throw away. Well, another was intramission theories of vision. Aristotle, Democritus. In this, that objects sloughed off little replicas of themselves, which conveniently size themselves to go to your eye. This one we know is wrong too. There were combined theories. In the combined theory, sort of a pneumatic theory, pneumatic means air theory, is that the light would illuminate the objects, and then your eyes would emit little particles of light. And that would activate the air in between and allow the replicas to travel in between. Clearly wrong. Ibn al-Haytham came up with our modern theory of vision. And in this, the modern theory is the light illuminates the scene. Every individual point on the scene radiates light, which enters your eye. This is how vision works. And there's more to it, though. Optics is not just the eyeball. Vision is not just the eyeball. It's also what's going on in the brain. So this is from his textbook on this. What we now know for vision is that we have an object. It gets focused upside down and flipped left for right on the back of your eyeball. And Kepler is given credit for developing this. Well, this was too much for Ibn al-Haytham. He stopped the rays before they were inverted and said this was the sensitive part of the eye, and you've got an image that's right side up. He got that wrong. Can't be too hard on him, because Leonardo da Vinci also got it wrong for the same reason. Only when Kepler came along did he get it right. So his book on optics was translated into Latin. We see Al-Azain's problem, Ibn al-Haytham's problem, other ways. If we take a spherical mirror, light bounces off a point into your eye. If I move the light source up, where on the spherical mirror does the light hit? How do you solve for that? The proof that that point in the mirror cannot be found by the standard ruler and compass methods of Euclidean geometry was only solved 10 years ago. So this is modern stuff as well. This is also called Elhazane's billiards problem, because if you're playing pool on a spherical pool table, where do you hit the ball in order to hit the 8-ball? Al-Haytham addressed the problem of the camera obscura and it projected images of the camera obscura. And light and colors don't mingle in the air. An experiment we're going to do after the break is this one. We have 3 different light sources, and we have the wall on the other side going through. Well, those lights go through. We know that. That light only goes to here. We know this. And so if we block off one of the lights, it blocks off only this one. It doesn't block off everything. It's actually not that obvious that this should be the case. Like, for example, if we're putting hoses through there, well, one water hose would hit the back wall, but if we're doing 3 water hoses, things are all going to get mixed up in the middle and the water's never going to make it the other side. So it remains to be proven, before you can accept this, that light, when it goes through a constricted region, doesn't intermingle. Another experiment we're going to do is, Al-Haytham translates this, shows refraction. So he appears everywhere. Kepler, who's given the credit for our modern theory of vision, it's amendments to Vitello. Vitello was called Alhazane's aide for having just plagiarized Alhazane. His influence is broad, and unfortunately, it's very little known in the Western world how much we are dependent on his developments.